Hi and welcome to this video about sessions with APIs. In the previous video you might recall we talked about sessions and what they contain, and if you haven't watched that video I highly recommend you go and watch that first before looking into this video. So what I want to do here is to show you some APIs that are related to sessions and other objects that are part of sessions like Windows stations and desktops. So as a quick reminder, we know that a session is an object that contains a bunch of other objects that can be shared between processes that belong to the same session. And of course, there might be multiple sessions on a system, and typically there are two sessions. Session 0 is always there. This is where system processes and most services run in, and session 1 or whatever number that may be is used for the first logged in user, if there is a logged in user to begin with. But now I want to dig into the APIs. So what I've done here, I've already opened up Visual Studio 2026. I've created a simple console application as I typically do. And then we have here two includes already added, which is for Windows.h and stdio.h to get the very simple printf function. And so in order to start, I want to enumerate sessions. I want to see which sessions or what sessions exist on my system. So for that we can use the function WTS enumerate sessions. However, all the WTS, which is the Windows Terminal Services APIs, which is really more generally applicable to sessions, is in another header. So we have to actually include another header here to get access to that. And this one is called WTS API 32. Of course, 32 is just a number which is there as some classic artifact. Don't take that too seriously. It works on 32 and 64-bit numbers. Systems. And so if you look at WTS enumerate, you can see you can enumerate multiple things like listeners, which we're not going to talk about, processes. We can even enumerate processes using this API. In fact, I think I demonstrated that in some older video a couple of years ago. And then we have also enumeration of sessions, which is what I want to use here. And there are two functions for that: enumerate sessions EX, which might provide a bit more details. Let's go with that. The first parameter is a handle to a server. We can use an API called WTS open server to open a handle to a different machine, enumerate stuff on that machine. So WTS API is really more generic in nature, but for our purposes, we're going to just enumerate stuff on the local machine. So I can pass null here as the handle to the server. There's just a constant for that, but null is what it actually boils down to. The next parameter is called level, which is a pointer to a dword. This is kind of weird, but basically it's a way to indicate how much detail I would like to get for the call. And right now there are only two levels supported, 0 and 1, and 1 provides more details. So I need to go ahead and put 1 here and provide the address of the variable. This is kind of weird. My guess is that it also returns the highest available level because otherwise it would make more sense to pass the number by value normally, not using the address. But it is what it is, and I'm going to just use it to make it work. Then there's a filter parameter we don't care about, which basically means that we can technically focus on a certain session perhaps, but we want all sessions. And then the result is obtained using this weird pointer of type WTS session info1 and a pointer to that. So let's go ahead and declare such a pointer. We have info and then 1, that's level 1 thing. So we have this, let's call that just info for short. And notice this is a pointer. So the idea here is that the API itself is going to perform the allocation. I'm going to pass the address to this pointer. So it's a pointer to a pointer, and that pointer is going to be overridden with a value that points to memory allocated by the API itself. It makes sense because otherwise I would need to know upfront how much memory to allocate. And since the information provided also contains strings, it's going to be pretty tricky to do. And so instead this API says, you know what, don't worry about it. I'm going to allocate the memory for you, but of course you'll have to free it yourself with the appropriate API later on, which we will do, not a problem. The last parameter is just an indication how many sessions we have to work with in the array of sessions returned. So this is the number of sessions that have been enumerated. So if this succeeds, it returns true, we can go ahead and do something with it. And so I'm going to create a loop here. that runs from 0 to count, that's number of sessions. And then we can do something with information. So let's go ahead and display some details about the session, each and every session. So the first thing we have is a session ID. I want to display that. Then there's some kind of name for the session. So let's display that as well. This is a friendly name for the session. And then we'll see that we can also get a username that is logged into that session if there is one. So I'm going to specify that with a domain / username format, the classic format that Windows supports. So let's go ahead and see what we have here. So we have info at index I, that's session I. Here's the information we get from the data structure. So first we have the session ID, of course, and then we have some other things like the session name. So let's just use that as well. And then we want to get the username. The username is comprised of the domain name, which could be, of course, just the name of the local machine if I'm not connected to any particular domain or not logged into a domain, which is the case for my little system here. And then we have the username. So we can display all that. The last thing that we have here actually, which could be interesting, is the state of the session. There is a state for the session, which I'll show momentarily. So let's have a % here for some parentheses and just display that while we're here. The state is enumeration, so we can't just display the string as is. We'll have to write some helper code to do that, but let's just at least get the number. And then once we're done with the loop, the nice thing to do is to free that memory, and there's an API for that to free all the stuff that is being allocated by the WTS APIs, and it's called WTS free memory. I'm going to pass info here and we should be done. So if I go ahead and try to compile that, we can see that it compiles fine but doesn't link. And the reason is that the API is actually implemented, the WTS API, in a separate DLL, and we have to add the import library for that, which is not added by default to new projects. So you can use the project properties to add that, or more simply, just to use the pragma comment here to give the linker information to add another import library, which happens to be called WTS API 32. So it makes sense, very similar to the header name. If we compile that now, it seems to work fine. Let me press Ctrl F5, and here goes. We get these two sessions here. So we have two sessions, session 0, which is called services. That's the friendly name for session 0. And session 1 is called console, which is the default name or the friendly name for the session that's currently being used with interactively. And you can see that I'm logged into that session. And for the user for session 0, there is no particular user, because really it's the system account and there's no particular user logged into that session. So we just get nothing for the username and domain name. The status, on the other hand, the state of the session, we have 0 here and 4 here. So what is that? What does that really mean? So if you look at state, if we press F12 here, we can see it's enumeration, and it's called WTS connection state. And you can see that 0 means active. So my console session is active because I am using the machine right now. And the other session, the session 0, was with a value of 4. So 4 is disconnected, which means there's no one is logged into that session interactively. There's no like direct client, which makes sense. And this is kind of what we get for this session 0. Now, of course, we can take that and try this on a different machine. So if I take this executable, I'm copying it from Explore on my other screen, and take that, say, to some virtual machine that I have here. I'm going to paste in the executable and just run it here. So you can see in this case we have 3 sessions. One of them is session 0, which is the services session. That's where the services run and so on. And it has the same state as before. And we have the session 2 here. Session 2 has this weird looking name that was generated by Windows as part of the remote desktop that I'm kind of using in Hyper-V here. And this is where I'm logged in right now. This is the active session. Notice the state is 0. And there's another one, which is the console session. That's the one that kind of directly is connected to the system, which I'm currently not using. and it has no user currently working with it. The state is number 1. We can go back and see what 1 is, seeing that it is connected, but it is not active. So there is something there, but it's currently not actually being used. And you might be wondering about the numbers of sessions. So usually numbers of sessions, these IDs, are not repeated if you just log off and log on again. Only when you restart the system, everything starts from scratch, from 0. So for example, if I log off here and then log on again, in any system really, you'll find that even though you're logging in with the same user, the session ID is going to be incremented. The previous one is just gone. So that's just the way Windows manages session IDs, but of course it could be managed differently by reusing IDs that are not in use right now. But this is how it works in practice. Okay, so now that we have a bunch of sessions, great. What else can we do with that? We know that sessions have various objects. The main one is a Windows station or Windows stations. How about enumerating Windows stations? Okay, so there's a function for that that's called the enumerate Windows stations. Enum Windows stations seems to be pretty straightforward. And as you can see here, there's a little problem here in the sense that you cannot enumerate Windows stations in a particular session. There's no session parameter here that you can pass into this API. Instead, what happens is that you can only enumerate Windows stations in your session, that is in the current session. So we can start with that. We'll see if we can get around that in some way, at least in some example. But let's start by just using this function. And what the function requires is some callback, and this callback is based on some type. We can try to go and look for all these type defs here, and eventually we'll see it's something like this. We get with the callback, we get a pointer to a name for the Windows station, and whatever parameter we passed in as a second parameter to the API. And we return a boolean to say whether we'd like to continue enumerating or not. As long as we return true, we'll get another callback and another one, as many Windows stations as exist in the session. And so we need to pass some function here, and I'm going to just use a lambda function here for convenience. So I'm going to get the name of the Windows station and the L-param, the other parameters, I don't really care about that. So I'm going to just use that, and then we can display some details about the Windows station. So we can say Win station, well, let's just write here something like Windows stations, and just display each one with its name. You can see we don't get a lot here. We just get the Windows station name, which is a bit disappointing perhaps, but we'll still be able to do something with it. But let's go ahead and display that for now. And we're going to return true here to indicate that we'd like to continue the enumeration until we are done with all the Windows stations that we have. Okay, so let's give it a shot. Let's press Ctrl F5. And this is what we get. We get that we have two Windows stations. One of them is Win*0, which shouldn't really be a surprise. We mentioned that in the previous video, that every session must have a Win*0 Windows station, which is the interactive Windows station, the only one that can accept any kind of input if that session ever becomes active. And then there's another Windows station here which has a bizarre name. It's not that bizarre, but it does look bizarre, at least for now. Maybe I'll get to that in a different video. So we have two Windows stations in the current session. We can verify that by using the WinObj tool we've seen in the previous video. So let's make sure that we actually get something that makes sense. So we're talking about session 1 here. Here's the Windows station right here. You can see that's exactly what we get. We get these exact two names as we expect, at least as we hope. And so it seems like it's providing the correct information. Now, if I want to see what's going on in session 0, say, we know that there's also Windows stations there potentially. In fact, we know that they're provided also under a Windows directory here, but not under 0, but instead it's here under the root. So we have these Windows stations right here that are part of session 0. Can we enumerate them in some way? So technically we could enumerate them using the object API here, which is not provided as a document API, but I have described how to use that in the Windows Native API programming book that I wrote recently. And maybe I'll show you how to do that in a separate video, but maybe for subscribers only, just to make it a bit more interesting. But maybe there's another way we can get to that. We can definitely give it a shot. And so one thing we can do is maybe run this application from session 0 itself. If we can do that, then enumerate of Windows stations here in Windows stations should give us the Windows stations in that session 0. So how can we run something in session 0? That's not necessarily very easy. We typically need to have some kind of service do that for us. But let's see if we can try some other way, although I'm not going to do too much here. I'm just going to use an existing tool, and this tool is called psexec. So psexec is a sysinternals tool. In order to run it, you have to launch an admin command window, and psexec allows you to do various things. Its main purpose is the ability to run something remotely, that is, copy something from your machine to some target machine and run that on that target machine. But one of the other things we can do is to run stuff here using a system. And so we can use that to run something under system using a -s. So that's going to run something under system. So if I open a command window here, it might perhaps run under system. The problem is that it may or may not work as we hope. Let's see. We can say who am I, and it does seem to be that I am system. However, am I running in session 0? We can check, or at least try to check with Task Manager here, for example. So do we have some CMD here that is running in session 0? Let's see. So indeed there is something here running in session 0. So now perhaps we'll be able, this is probably our new process there, we'll be able to maybe get the Windows stations in session 0. Okay, so let's give it a shot. Let's move to the correct directory. So that's going to be YouTube video and YouTube code, and then we have sessions, and I don't get completion here, which is a bit annoying, but let's just keep at it. And if we look here, we have the sessions application. Let's run it. You can see it works. We get the Windows stations in session 0 because now the caller is running part of session 0. And that's why we're able to enumerate that session in terms of Windows stations at least. Which means that if you want to get to a particular session, you have to run something within that session. Otherwise, Windows stations just doesn't have the power, doesn't provide this capability of enumerating Windows stations in some random session or arbitrary session we are choosing. Okay, what else can we do here? We have a Windows station here. So how about desktops? We know that Windows stations can contain desktops. So let's see which desktops are contained within each Windows station. Of course, we'll have to do that on a per session basis as we've seen here. So let's try to look at that from our current session and maybe run that in multiple ways. So how are we going to do that? So let's create a function like display desktops. So we have some better code organization here and passing the name of the Windows station. So here's display desktops. Let's write it. And we have the name of the Windows station. So great. What do we do next? And so in order to enumerate desktops, there is a function for that. Seems to be easy enough. It's called enum desktops. However, its first parameter is a handle to a Windows station. Windows station is a kernel object, is a kind of kernel object. So we have to open a handle to that Windows station. So fortunately, there's a function for that. It's called open Windows station. It does require the name, and that's why we're happy we have that name. There's an inheritance flag, which we don't care about. And then there's an access mask that asks us what kind of access we'd like to have with that Windows station. And so there's a bunch of access masks for that. For example, we would like to be able to enumerate desktops. So let's ask for that. I think that should be good enough. And so we're going to get a handle to the Windows Station here. If that works and we get something which is not null, then we can move forward. Otherwise, of course, there's nothing we can do. So we have the Windows Station here, and just like before, there's a callback. It's the same idea. It's going to be called for every desktop that is discovered and give us the name of that desktop. Let's just verify. We can go to documentation, of course, but here's the procedure here, and again, it's the same thing. It wants just give us the name. That's all we can get. Okay, we can work with that as well. So we have a desktop name here. That's what we get, and there's the free lparam parameter, which we don't care about. So for each desktop, we can display some details about that. Let's say desktop and provide the name. That makes sense. So here goes. We have desk name. And we're going to return true to indicate that we want to move to the next desktop. We're not giving up. We want to get the full list of desktops. Once we're done, we can then close a Windows Station. So notice that close the Windows Station has its own function for closing a handle. It's not using the normal close handle. There's a reason for that, but it's not that important for our purposes. And then we can just try to test it out. So let's go ahead and do that. So here goes. I've run this in my default session, of course, session 1, where I'm logged in. And you can see we have Winsta 0. It has two desktops that I mentioned in the previous video. We have the default desktop where you see the stuff that I'm recording right now, and there's the WinLogon desktop, which is used to show the WinLogon UI that you're familiar with when you press the Control-Alt-Delete sequence. And then the second Windows Station has its own bunch of desktops. It's unclear why these desktops exist and what do we have in them, but at least we know that we have those. So what else? Maybe we should try to run the same thing here in session 0 while we have the chance. So here goes. So in this case, we have in Winsta 0, we have the default desktop, the WinLogon desktop, and there's another desktop called Disconnect desktop, apparently. It's just a name, of course. We don't know necessarily what that is used for, but maybe we can guess. And then we have some other Windows stations here that don't have any desktops, but then there's another one called MSS Windows Station that has a desktop called MS Restricted Desk. That's interesting. Maybe it has some interesting features. What can we do next? Now that we have these desktops, can we go further down? You might recall that desktops have windows. So maybe we can enumerate windows in a desktop. And so there's a function for that. So there's enum desktop windows. This enumerates all the top level windows that exist in a particular desktop. And just like before with Windows Stations, it requires a handle to a desktop. And for that, there's a function, open desktop, which you can use in order to open a handle to a desktop. And then you can do various things with that desktop, such as enumerate desktop windows. I also mentioned the function switch desktop in the previous video, which allows you to switch to a different desktop. If you have the power to do that, then again, you'll have to first open a handle to the desktop of your choice and then perform the switch. And so you can then continue here enumerating top level windows, which could be very interesting, by the way, especially maybe in session 0, who knows what's there. But I'm not going to do that here. I'm going to leave that to you as an exercise. The code is going to be, of course, in my GitHub repo, and you can take that code and continue working with that and get more details, more information about what is going on within a session. So hopefully you enjoy that, and I'll see you in the next video.